Okay, systems of linear equations, test review. Number 1 through 6, we're solving by graphing. So I'm going to graph the first one, that's y equals, because when y is alone, I can graph right away. So my y-intercept is 6, because that's my number without x. This is my x-axis, y-axis. And my slope is my number with x. And so my slope is 3, which I make a fraction as 3 over 1. And it's positive, so I'm going to rise 3. And remember, the bottom number always goes right. So up 1, 2, 3, right 1. Well, I don't have any more space to keep going, so remember, you can do opposite, opposite, and go down 3, left 1. Okay, and go most of the way across, especially on your first equation. And y'all, if you don't draw your lines on the test, I will take off points. It doesn't have to be a perfect line. I know I just used a ruler. You don't have to use a ruler. You just have to draw a line. Okay, now my other equation's in standard form. X and y are on the same side. So if you wanted, you could solve for y and do it like this, but I'm just going to use the cover-up method. So remember, if I cover up y, because y is 0 for my x-intercept, okay, 3x equals negative 6, I would divide both sides by 3, and I get my x-intercept equals negative 2. If you'll notice, is my same as my other line. Okay, and then I can find my y-intercept by covering up x. Well, I would divide both sides by negative 1, and I get y-intercept is 6. Well, what do you notice? They are on the same line, meaning they are the exact same line. So this is going to be where they touch everywhere. They are the same line, meaning my solution is IMS, infinitely many solutions. And my kind of system is dependent and consistent. Dependent and consistent. Remember, dependent because it's everywhere, and consistent because there is a solution. Okay, so let's try the next one. So again, I'm going to graph the one that's already y equals first. So plus 10 is my y-intercept. So on my y-axis, I'm going to put a point at 10. 3 is my slope. M equals 3, which is the same as 3 over 1. Now, it's rise 3, run 1, but I can't do that. So I remember I can do opposite, opposite, which would be down 3, left 1. So down 1, 2, 3, left 1. 1, 2, 3, left 1. Okay. So I'm going to draw my line, and there's that line. Okay, so now when I draw my other line, I'm going to do the cover-up method. So when I cover up y, I get x equals 6. So my x-intercept is 6. When I cover up x, well, I divide both sides by 2, and I get my y-intercept is 3. So on my x-axis, I'm going to put a point at 6, and y, I'm going to put it at 3. I can't find the middle. There it is. 1, 2, 3. Okay, now I need to find my slope so I can figure this out. So you can do rise over run, rise 3, run 6, or you remember can do opposite of a over b. So a is 1, and the opposite of that would be negative 1, over b is 2. So my slope is negative 1/2, which means I'm going to go down 1, right 2. Which, if you notice, does work, and I can do opposite, opposite to go back towards my line, which would mean they're going to touch right here. So their solution is negative 2, 4. Okay, and the kind of solution is independent and and consistent. Consistent because there is a solution, independent because there's only one. We're making a video. Okay, so let's look at number 3. Again, I'm going to graph the one that's already y equals. So my y-intercept is -6. Okay, my slope is -3/2, which means I'm going to go down 3, right 2. Now I can't go any further, so I can do opposite, which would be up 3, left 2. Okay, so then I'm going to do standard form on the other one. So when I cover up y, well, if I divide -1 by 2, that gives me a fraction, and I can't graph a fraction. So I'm going to find my y-intercept, which would be divided by -1. So my y-intercept is +1, and then I need to find slope. That was loud. Okay, so slope is opposite of a over b. What's the opposite of a? Well, that's -2 over b is -1. So it'd be a +2/1. So y-intercept is 1, and my slope is rise 2, 1, 2, run 1. So I can also go down 2, backwards 1. And there's my solution. Remember, if you don't draw the lines or plot the points, you will get points off. So my solution here is -2, -3, which is independent and consistent. Okay, so let's look at number 4. So number 4 has 2 special cases lines. I want you to realize x equals -5 is going to be a Vux line, Vux. So vertical undefined x equals equation. So at x equals -5, which is here, I'm going to draw a vertical line. Okay? And then I have, this is a Hoy equation. So horizontal 0, slope y equals 2. So at y is 2, I'm going to do a horizontal line. So where do they touch? They touch right here, which is -5, -2. Or sorry, +2. Okay, and our kind of system is independent and consistent. Okay, on number 5, they're both in standard form, which is totally fine. So I'm going to start at the top. So on this one, I have x equals -9, because x has a no coefficient. Here, I'll divide both sides by -3 to get my y-intercept. And -9 divided by -3 is +3. Okay, and I'm also going to go ahead and find my slope, which is opposite of a, which is 1. So -1 over b is -3. So that gives me +1/3. So x is -9. Y is 3, and I'm going to rise 1, run 3. Okay, on my other one, I get, when I cover up y, I get x equals -4. When I cover up x, I can divide both sides by 2, and I get y equals -2. So I have x is -4, y is -2. Okay, and then my slope is opposite of a over b, so -1 over 2. So I'm going to go down 1, right 2. which did bring me to my next point. I can also go up 1, left 2, which is where I find my solution. So I have -6, 1. So it's independent and consistent. Okay, last one on graphing. Okay, I'm going to graph the bottom one first. So I have a y-intercept of -5 and a slope of -4, which I put over 1, so I'm going to down 4, right 1. Can also go up 4, left 1. Okay, and then my other line is going to be standard form. So my my x-intercept, well, I would divide both sides by 3, and that gives me -4. So for my y-intercept, I would divide both sides by -2, and I get 6. And again, I would find slope, which is opposite of a over b. So opposite of 3 is -3 over b is -2. 2 negatives makes positive. So I'm going to rise 3, run 2. And I found my slope right away, or my answer right away. Now, I didn't have an example of what no solution would look like, so just as a refresher, if we graph something with no solution, it would literally just be 2 lines that are parallel, so they have the same slope. Okay. So now, number 7, 8, 9, and 10 say to do substitution, to practice substitution. So that's what we're going to practice. So remember, on substitution, you want something that has a variable already alone. So this has y alone that equals x over 2. So in the other equation, I can replace y with x over 2 and solve. So I'm going to do that. And instead of y, I'm going to plug in this x over 2. Well, these 2's cancel, and we get x equals x plus 4. So I'm going to subtract x from both sides. Well, it zeroes out on both sides, and I end up getting 0 equals 4. True or false? Well, that's false. So this is no solution. Okay, number 8 is also already set up. So I have x alone. X equals 2y minus 1, so I'm going to replace x with 2y minus 1. So 4, 2y minus 1, minus 3y equals 21. 4 times 2y is 8y. 4 times -1 is -4. Minus 3y equals 21. So I'm going to combine like terms before I keep going. 8y minus 3y is 5y. Add 4 to both sides. And I get 5y equals 25. Divide by 5, divide by 5, I get y equals 5. Now I'm not done, that's only half of my answer. So remember, your answer is an x comma y solution, so I know y is 5. And I can plug it into either one. So I'm going to plug it into the first one. So I have x equals 2y minus 1, so I'm going to replace y with 5. So I get x equals 2 times 5 minus 1. Well, 2 times 5 is 10. Minus 1 is 9. So if you struggle with math in your head, that's totally fine. If I could type right on the calculator. So it gives you 9. So my solution is 9, 5. Now remember, you can check your work. So 2 times y, which is 5, minus 1 should equal 9. That's what we just did. That worked. And then 4 times x is 9. Minus 3 times 5 is y should equal 21, and it also worked. Therefore, that is my solution. Okay, so looking at number 9, I don't have a variable set up yet. I don't have anything alone. So I need to do that. I'm going to do it here. I'm going to get this y by itself. So I'm going to subtract 7x from both sides, which makes that go away. So now I have negative y equals 36 minus 7x, but I cannot have a negative y. So I'm going to divide by negative 1, or just make all the symbols opposite. So I get y equals negative 36 plus 7x. Now I have something to substitute in. So I know y equals this, so I can replace y with that. So I'm going to rewrite the first equation, 5x plus 3, and instead of y, I'm going to plug in this negative 36 plus 7x equals negative 4. And I'm going to solve. So 3 times 36, I'm going to bring down my 5x. 3 times negative 36 is negative 108. 3 times 7x is 21x. Equals negative 4. We'll combine like terms. 5x plus 21x is 26x. Okay, now I'm going to add 108 to both sides. And that'll give me 104. I'm going to divide both sides by 26. Gives me x equals 4. So again, there's half of my solution. Remember, your solution's in x comma y. So x is 4. And I'm going to plug it into the other equation, or it doesn't matter actually. And I'm going to replace x with 4. So 7 times 4 is 28. So I'm going to subtract 28 from both sides. I get 8. But I can't have a negative y, so I divide both sides by negative 1, or flip both the symbols. Y equals negative 8. So 4 negative 8 is my solution. Bless you. Okay, number 10 also does not have a variable all alone yet, so I'm going to get the x alone by subtracting 6y on both sides. And x is positive, so I don't have to change anything. I get x equals 32 minus 6y. So because I know x equals this, I can replace x with this. So I get 2 times 32 minus 6y plus 3y equals 10. So 2 times 32 is 64. 2 times negative 6y is negative 12y. Bring down what I haven't used, plus 3y equals 10. Combine like terms, and I get 64 is minus 9y equals 10. Minus 64, minus 64. Divide by negative 9. And I get y equals 6. So because y equals 6, I'm going to plug in to either equation. I'm going to do the second one. So I get x plus 6y equals 32. And I'm going to replace y with 6. So x plus 6 times 6 equals 32. X plus 36 equals 32. minus 36 minus 36. X equals negative 4. So there's our solution. Okay, now the next three say to solve by elimination. Remember, I call that big addition. It's where we want something to eliminate right away. Okay, so if you look at the x's and the y's, nothing eliminates right away. But I see that one of the y's is already positive and the other one's already negative, and I could turn this into an 8 by multiplying by 2. So I'm going to multiply the second equation by 2. I'm going to rewrite the first equation. And then I have 10x minus 8y. That gives me negative 52. Because I wanted, hold on. I wanted this negative 4y to turn into a negative 8y, so they eliminate. Remember that? So that's why I got 2. And knowing that, I'm going to do big addition. So 6x plus 10x is 16x. 8y plus negative 8y, well, that zeroes out, which is what we wanted. Equals 20 plus negative 52 is negative 32. Okay, now I'm going to divide both sides by 16, and I get x equals negative 2. So then remember, I can pick either equation. It's just like substitution now, and plug it in. So I'm going to pick the first one because they're positive. I don't know, 6x plus 8y equals 20. And I'm going to replace x with negative 2. Well, 6 times negative 2 is negative 12. So I'm going to add 12 to both sides. And I get 8y equals 32. 32 divided by 8 is 4. So my solution is negative 2, 4. Okay, on this one, again, nothing cancels right away. But I can make the x's and the y's both cancel pretty simple. Let's do the x's. So they're both positive, so I need one to be negative. Can I turn 4 into an 8? Yes, by multiplying by 2, but I need it to be a negative 8, so I'm going to multiply by negative 2. So that gives me negative 8x plus 6y equals negative 44. Well, when I rewrite that other equation, what happens? They all zero out. And it gives me 0 equals 0, which is true. Therefore, my solution is IMS, infinitely many solutions. Okay, looking at number 13. I would cancel the y's because one's already positive, one's already negative. 2 can't turn into 3, but they can both turn into 6. So 3 times 2 is 6. Negative 2 times 3 is negative 6. So that's what I'm going to multiply both equations by. So 2 times 8x, 16x. 2 times 3y is 6y. 2 times 5 equals 10. Watch your mouth. 3 times 6x is 18x. 3 times negative 2y is negative 6y. And 3 times 9 is negative 27. So I'm going to do my big addition. (16x plus 18x is 34x. 6y plus negative 6y is 0. And 10 plus negative 27 is negative 17. Divide both sides by 34. And I get x equals negative 1/2. Okay, which is totally fine. That's an answer, that's a solution. So we're going to plug it into one of the problems. Doesn't matter which one. So I'll plug it into the second one. It's got smaller numbers. X equals -1/2. Whoa, I wrote y. So I'll plug it in right there. So that will give me -3. So I'm going to add 3 to both sides. I get -2y equals -6. Divide by -2, divide by -2. Y equals 3. So my solution is -0.53. So just a reminder on both of these, no solution is when it's false, and when it's true, it's IMS, infinitely many solutions. Also, another thing we could talk about here is this is independent and consistent, right? Because there's one solution. This is dependent and consistent because there's infinitely many solutions. Independent and consistent. Now, what would this one be? Does anybody remember what it is when it's no solution? It's inconsistent. So these are independent and consistent, independent and consistent, independent and consistent. This is dependent and consistent. Okay, let's keep going. The rest is a lot less work, which is nice. Okay, so for the system, combine the equations that the y terms eliminate. So I want to eliminate the y terms. Well, 5 and 3 can't turn into 5, but they can both turn into 15. So I would multiply the top by 3, and I'm going to do the bottom by -5. So 3 times 3x is 9x. 3 times 5y is 15y. And 3 times -15 is -45. Yeah. -5 times 2x is -10x. -5 times 3y is -15y. And -5 times 4 is -20. So it just wants me to eliminate the y's, so I don't have to solve for the other letter. I'm just going to solve for x now, because I eliminated the y's. That goes away, and I'm left with -x equals -65. Why did I put x? 5. Well, I can't have a -x, so I divide both sides by -1, and I get x equals 65. It just wanted me to eliminate the y term. Okay, so this one says eliminate the x term. I have 4 and 3. Okay, I know that 3 cannot turn into 4, but they can both turn into 12. So I'll multiply the first one by a -3 to give me a -12, and the bottom by a +4 to give me a +12, because a -12 cancels a +12. -3 times 4x is -12x. -3 times 5y is -15y. -3 times 7 equals -21. 4 times 3x is +12x. 4 times -2y is -8y. And 4 times 34 is 136. So now that I eliminate them, the 12s cancel, and I get -23y equals 115. When I divide both sides by -23, I get y equals -5. Okay, number 16 says, which equation, when paired with this equation, would create a system with exactly one solution. When it's one solution, I want you to remember, so when it has infinitely many solutions, it's the same slope and same y-intercept. When it's no solution, it's same slope, different y-intercept. So the way that they can be one solution is just have a different slope. Okay, so if I just find my slope, m equals -2 over -5, which is positive 2/5, I just need one with a different slope. Well, positive 2/5, this is the same slope, so that would be, and my y-intercept, I don't know, either IMS or no solution. Same slope, so that would be either IMS or no solution. This has a slope of what? 2. So that would be a different slope. Here, opposite of A over B would also be the same slope. So C would be your answer. Okay, here's a table. It says 3 different systems of equations are represented below. Graph, solution set, so on and so forth. Okay, here, what would our solution be? Well, let's look. Okay, so we can solve them. I know that this one is going to have a slope of -1 over -2, which is a positive 1 over 2. While this one has a slope of -1 over 2, which is a negative slope. So these have different slopes, therefore they're going to have a solution. They're going to touch. Okay, here I have to find my slopes. That's all we're doing now, is finding your slopes. So opposite of A over B would be -3 over -1, which is 3 over 1, which is just 3. Here, this is not standard form, so I could divide everything by 3, and that would give me my slope. Well, what's 9 divided by 3? That's also 3. So these have the same slope. So we know they're either going to be no solution or the same line. So we have to figure out their y-intercept. The y-intercept here is going to be -3. My y-intercept here is also going to be -3 if I divide both sides by -1. So they have the same slope and same y-intercept, meaning they're the same line. So my graph is F, and they're infinitely many solutions. Okay, meaning this one has different slopes. One's positive 1/2, one's negative 1/2. So knowing that, I know that I'm going to have a solution, and it's going to touch once. Okay, and again here we can find our slopes just to prove it. My first one is going to be -1 over 2. My second one is going to be -2 over 4, which simplifies to -1 over 2, so they have the same slope. Okay, my y-intercept for the first one would be -2. My y-intercept for the next one would be -3. They're different y-intercepts, therefore they're going to be parallel and have no solution. So different slope, same slope, different y-intercept, same slope and y-intercept. Almost done. Okay, this one says 3 different systems. Graphs are graphed below. Identify which one to describe. Okay, so this one is just one line, meaning we probably have 2 lines on top of each other if we're talking about a system. So that would be infinitely many solutions, which is dependent and consistent, so F. This is 2 lines that don't touch and they will never touch, so this is no solution, which is inconsistent because there's no solution. Okay, this touches once, so there is one solution, and it is independent and consistent. Okay, now number 19 and 20 doesn't matter how we solve it. We do have to come up with the equations, and we have to define our variables. Okay, so it says a music store receives shipments of recorders and harmonicas. A shipment of 5 recorders and 4 harmonicas costs $62, and a shipment of 10 recorders and 3 harmonicas costs $84. So I know that I have 2 different shipments, which means I'm going to have 2 different equations for those 2 shipments. And I have 2 unknowns, okay? I have recorders. I don't know the price of recorders because it tells me find the cost. So I don't know the price of recorders. And I don't know the price of harmonicas. So my first shipment is 5 recorders plus 4 harmonicas, and it equaled $62. My second shipment was 10 recorders plus 3 harmonicas, and it cost $84. So I'm going to do elimination because I see right away that I can multiply this top equation by -2, and that would turn this r into a -10, which would cancel with this positive 10r. So I'm going to rewrite it just underneath. So I get -10r minus 8h. 62 times -2 is -124. So I'm going to use those 2 equations because I didn't change that second equation, and I rewrote the first one by multiplying it by -2. So when I do big addition, these cancel. I get -5h equals -40. Divide both sides by -5, and I get h equals 8. So I know the cost of harmonicas was $8, but it wants me the cost of the recorders and harmonicas. Okay, so then I need to plug in to find recorders. So it doesn't matter which equation I use. I'm going to use the original first one, and I'm going to replace the h with 8. So I get 5r plus 32 equals 62 minus 32 on both sides. Get 5r equals 30. Divide by 5, divide by 5. And I get r equals 6. So I know recorders cost $6. Harmonicas cost $8. Bless you. Remember, word problems get word answers. Okay, at a professional basketball game, the turnstile count showed that 17,406 people paid admission. The total cost received for tickets was $133,372. Without actually counting the ticket stubs, find out how many paid for reserved seats, $10 each, and how many paid general admission at $6 each. Well, the 2 things I don't know is how many tickets. So I have reserved seats, number of reserved, and I have general seats, so number of general. So remember, money goes with money goes with money. So reserved seats were 10, so 10R plus 6G equals my total money, which is $133,372. Okay, and then the amount goes with the amount goes with the amount. Well, these represent the amount, so R plus G equals my total number of tickets, 17406. That's a G, not a 6. So this one's pretty simple to do elimination. I can multiply either equation if we want to get rid of R or G. I'm going to do G just to multiply by a smaller number. So I need this G to be a -6, so I'm going to multiply this equation by -6. So I get -6R minus 6G equals -104,436, and I'm going to rewrite that top equation. And I'm going to do my big addition. Yes. So I get 4R. My G's canceled. Two, 8, 9, 3, 6. I'm going to divide both sides by 4. And I get R equals 7,234 seats. And it wants to know how many paid reserved and how many paid general admission. Well, the nice thing is that second equation is going to be really simple to plug that into. Okay, so I know R plus G equals 17406. Y'all, technically we can just subtract that from the total, but I'm still going to set it up as an equation. 7,234 plus G equals 17406. So I get 17406 minus. So I have 101,000. Why am I putting the comma in the wrong spot? 10,172 general admission and 7,234 reserved.